Welcome back. So today we're going to be working on sine and cosine. So we're going to be starting on page 294. So if you want to go ahead and take that page out of your notebook. So starting with sine, I'll go ahead and zoom in just a little bit here. So we're going to be completing this portion up here first. So when we talked about sine before with our unit circle, we talked about sine is the y coordinate and our cosine is the x. Sine is the y, cosine is the x. So then when we come down here, then that's what we're going to be looking at when we're talking about the sign, whether it's positive or negative on our unit circle. So when we're over here in quadrant 1, our x value is going to be positive and our y value is going to be positive. When we move over to quadrant 2, now our x value is going to be negative and our y value is still going to be positive. Okay, when we move down here to quadrant 3, our x value is still negative, and now our y value is also negative, so sine is negative. Moving to quadrant 4, we have our x value is positive, but our y value is still negative. So we should have all of those boxes filled out there on that portion. Then we're going to be moving on to page 295 to the foldable. Looks like this. So on page 295, we're going to be starting out with sine. So we'll go ahead and flip to that one. And again, I'll zoom in just a little bit here so it makes that a little easier for you to read. So for sine, sine equals the O, which is opposite leg, over H, which is our hypotenuse. So when we set up our ratios, that's what we want those to be. So looking at sine of D, so I'm going to start over here with this angle. So the opposite leg is going to be 7. The hypotenuse is going to be my 25. So we have 7 over 25. I cannot reduce those, so I'm going to leave it like that. But if you remember from working with tangent, we are going to change that to a decimal. So I'm going to just type into my calculator 7 divided by 25. That does happen to be a terminating decimal, so it stops. So 0.28. So we can put equals 0.28 since it is exact. Then we're going to look at sine of F. So now we're looking at angle F. We want the opposite, which is 24, over the hypotenuse, which is still 25. So again, I can't reduce that, so I'm going to look at my calculator, typing in 24 divided by 25, and we get a terminating decimal again of 0.96. So equals 0.96. Okay. All right, so the next part is now we're going to be looking at a triangle and we're going to be finding one of the missing sides. So we're going to find T for this one. So in order to do that, we're going to use sine. So sine, always followed by an angle measurement. So the only one we have here is 65. We could use the complement that's over here. However, for this one, we're just going to use what they gave us. So sine of 65 degrees equals, we want the opposite leg over the hypotenuse. So the opposite is T, the hypotenuse is 8. Okay, so now to solve for this, we're going to multiply by 8 on both sides so we can get that out of the bottom. So we get 8 sine of 65 equals T. So then I'm going to be using my calculator and I'm just going to type it in exactly the way it's written. 8 sine and then 65, and then I can hit enter, and we're going to round this one to the nearest tenth, so it's going to be 7.3. So 7.3 is approximately T. Okay. All right, so this piece here, we're going to wait on that. We'll come back to that after we've talked about cosine. So let's go ahead and move down to cosine. So for our cosine, we're going to be using A over H. A is our adjacent leg, and H is our hypotenuse again. Okay, so looking at those for cosine of D, so I'm starting out with angle D again. I want the adjacent leg, which is 24, over the hypotenuse, which is 25. You'll notice that the triangles that I drew for sine and cosine are the exact same triangle. And you'll also notice cosine of D is the exact same ratio as sine of F. Okay, those are the same thing. So we can put equals 0.96 because we already figured that one right up here. All right, it's really important that you're seeing that relationship between the cosine and the sine. So F and angle D, those should be complements. Those should be complements. When we add those together, they add up to 90. So that's really important. So for cosine of F, that's going to be the exact same thing as sine of D. So if we look here from F, the adjacent is 7. The hypotenuse is still 25. And you'll notice it does come out to be the same as sine of D. And so we already have that decimal as 0.28. Okay, so then the last piece that we're going to do here for this part is finding U. So again, our triangles are the same on both of these. We found T for the first one, now we're going to find U. So using cosine of our angle, which is 65 degrees, equals the adjacent is U, and hypotenuse is still 8. Okay, so from here, I need to get that 8 off the bottom. So we're going to multiply by 8 on both sides, and I get 8 cosine of 65 equals U. So coming over here to my calculator, I'm going to type in 8 cosine of 65 and then hit enter. And I end up with this big long decimal again. So we're going to go to the nearest tenth, which is 3.4. 3.4. We're going to round that. 3.4 is approximately U. All right. So then the next piece here, I'm going to go ahead and turn this because we're going to be working with these two. So when I'm looking at this first one, it says we're going to write sine of 23 in terms of cosine. Now, if you remember, I told you that sine and cosine, they're complement of each other. The angles for those are complements of each other to be equal. So when we're looking at these, sine of 23 degrees equals cosine. Since they're going to be complements, I'm going to take 90 minus whatever this angle is, which is 23. So sine of 23 degrees equals 90 minus 23, 90 should be 67. So those are going to be equal to each other. The angles are complements of each other. So then since we're using sine and cosine, then those should be equal. So same thing when we come over here to cosine. Cosine of 65 degrees equals sine of what? Well, we're going to take 90 minus whatever this is, so 65. So cosine of 65 equals sine. So 90 minus 65, we get 25 degrees there. Okay, and again, those should be complements. So 65 and 25 should add up to our 90. Okay, great job with that. So the last piece that we have is this angle of depression. Now we talked about angle of elevation the other day when we were doing tangent. So today we're going to work on the angles of depression. So looking at this one here, Now the difference between our angle of elevation and our angle of depression, if you remember I said elevation, we're looking from the horizontal, like our eye level, up at something. So an angle of depression, now we have our eye level and we're looking down at something. So for this one, we're at the top of the slide and we're looking down to the bottom of the slipper slide. So for this problem, we have a 53-degree angle of depression. We know that the slide from the bottom of the slide, not the ground, but the bottom of the slide to the top of the slide is 12 feet. We want to figure out how long that slide is approximately. So in order to do that, I'm going to be using this angle of depression. I have a hypotenuse and I have an opposite. So that means I'm going to use sine of 53 degrees. So I can use my opposite leg, which is 12, over my hypotenuse, which is x. Okay, so I'm going to multiply by x on both sides because I want to get that x out of the bottom. So we get x sine of 53 degrees equals 12. Then from here, I'm going to divide by sine of 53. So those will cross out. So we get x equals 12 divided by sine of 53. So then I'm going to come over here to my calculator. I'm going to type that in. So 12 divided by sine of 53 and enter. And I get this 15.025 and it keeps on going. We're going to be rounding to the nearest tenth though, so that's 15.0. So x is approximately 15.0. Now if you remember, this is basically a word problem that we're working on. So we're going to give some real world value to that x and we're going to say the slide is approximately, we'll fix that, approximately 15 feet long. The slide is approximately 15 feet long. So what does that 15 represent is what we're trying to explain here in our sentence. So the slide is 15 feet long. Okay? All right, that is all that I have for you today. That should be everything in your green foldable. This is on page 295. So that's everything for that. So you're going to go ahead and work on the practice problems for sine and cosine. Those are on pages 299 to 301. Have a great day. I will see you in class.